Hey, hello everyone. Am I clearly audible and visible to everyone? A quick plus one should be very helpful. Just a quick check. Okay,
Just a
seems
quick
to be working
check.
fine. Okay, great to see. I think we'll be starting off in a quick 1 minute. We'll be talking about Atcoder, like educational DP contest questions, and we'll be solving them with the forms that we have learned. We're going to see how to kind of use them in a much neater way, right? And that's there. Let me just quickly just set up this particular thing. I have one good hardcoder question. Okay, which one? Which good hardcoder question do you mean? Okay, so let me just quickly open up. So how many of you have seen the forms videos as of now? Put this up on Discord. Great. So we would be using forms itself, like certain degree of forms would be needed for today. I mean, to most sense, and we would be. Let me just post this on. Cool. Let's start. So, can you please give some details about regarding the DP contest going to take place after workshop? Yeah, I'm going to give that details too. So that is going to be mostly on Sunday, and it's going to be related. It's going to be on DP itself, and it's going to be a priced contest depending upon the participation and stuff. So I think I'm gonna make a separate like announcement video on top of that. Like once we are done with day 6 as well. I waited for today and tomorrow just so that we can kind of complete things up, and then I'm gonna make a video on separately on that. Okay, so don't worry about that. Yeah, at the end we can take more questions too. I mean, I'm more than happy to answer any of your questions as well at the end. Okay, let's start with the Atcoder questions. Let's not get delayed and kind of go through all of these things. I'm gonna just quickly take Atcoder list. So I have certain lists which like we can kind of go through based on the forms that we have learned. Obviously in Atcoder you can see that towards the end. Let me open up the Atcoder contest page. I think you guys can see this now. On the Atcoder tasks, like there are like A to Z, right? Over here there are like multiple different problems which might not be able to we might not be able to solve using forms, like the last few ones which are very hard, right? And in this case we are going to solve the starting ones, like till maybe the part of L or so, because beyond M and on it is all optimizations and stuff, so we will talk about that. Okay, but I'm going to give you some brief ideas what these are. In fact, the M1 you'll be able to solve after tomorrow, like after day 6 content, okay, which is optimization in DP to specific sense. And today we're going to go through these few problems. Okay, the first problem that we can quickly go through is this. Yeah, the first question that I'm getting on the chat is, I have my interviews scheduled, what should I prepare? I mean, like every interview is different. I cannot really suggest you anything for that matter. Like I have been taking some interviews for some time now, but I don't think I'd be taking yours because I'm not taking any more for this month at least. The first one that we're going to take is prop 2, which is the second problem. I skipped out the first problem because it's much more simpler and we can actually solve the second part itself, so that we can kind of solve the first part also. Like the same thing, same code can work for the first one as well. Okay, so I'm going to give you a quick 1 minute time to read the problems in case you have not read the problems, and after that post that we're going to discuss the idea. I'm just also going to post the links on the chat in case you want to go through it. Hi for joining in. Okay, so go through the problem. It's like we have n stones, and in one step you can jump at most k steps. So remember the climb stairs problem that we solved in one of the first few sessions. Screen shared. Yeah, let me go ahead and screen share the things. Right, screen not visible. Okay, now it should be. Is it visible now to everyone? Can I have a quick plus one from everyone individually? Great. So frog 2 is the problem where we have like a similar version to, you can say, the what was the problem? Climb stairs, right? In one of the recursion videos. So over here we can, like, from a particular stone we can jump to this particular thing, and the cost, there is a cost of jump, right? In that case we could jump anyways and we had to find the number of ways. In this case, from I to any particular thing you have a cost of abs of the difference between the heights, okay? And we have to find the minimum total cost incurred before the frog reaches n. We have to find out the minimum cost to reach n, for that matter, okay? So how can we do this? How can we solve this? So we are going to use the framework that we have learned, okay? So first thing that we're going to decide for every problem, which is form 1, form 2, form 3, form 4, form 5, which form it is, and then we're going to model it up according to the form, okay? But I think for you guys the biggest question would be the form. If you know the form, even you guys can solve this one, okay? No, is there any other image? No. So essentially, like, I'm going to explain it up. So what we're kind of dealing with over here is, over here we have at any particular place you can kind of stand over, you are standing over here and you can go to k steps forward, right? Min cost till level, okay? Okay, that is one feasible thing. So what form can we use for this particular problem? You can jump for k different steps, and for each of these you have a cost, okay? You can move k steps, okay? For each of them you have a cost. You have to reach the nth cell and you are at the first cell, and for each of them you are given some cost. So which form does it suit, like, okay? So this actually feels more like form 1 or form 2. I would say it can be solved in both of them, okay? Ending can also be used, that's correct. That's why I say that it is form 1 and form 2, both are feasible. Personally I prefer for such questions form 2. Reason being is that it's not really a choice, right? At each cell you're deciding whether you take A or B or something like that, or take or don't take. It's more about finding a sequence, like there is a subsequence getting formed, right, between using the jumps, right? There is a subsequence getting formed using the jumps. So for such problems, whenever I see such subsequence getting formed, I try to use form 2. Okay, that's the rule that I have in my mind, that whenever I'm dealing with such things, I deal with form 2, right? What is the best way to reach dp of n comma k? I would not say k would be the best thing to keep over here, okay? We can use form 2. So the general state for form 2, the state that we keep is dp of level, okay, is going to tell me min cost to reach level, like what is the best path that ends at that level. Ending for form 2 is nothing but ending form. So ending form says that what is the min cost to end at this level. Yeah. So what is the best way to, that you such that you start from 1 and then you jump to certain things, and then you reach at a particular level. Okay, what is the best way to do this? Okay. Generally, I use form 1s for pick and not pick, or where there are multiple options to be placed at a particular place. That's where I use when I see a problem of subsequences, which means you have to find certain jumps or paths or things like that. I try to do it with form 2. I can show you form 1 solution as well. It's also possible using form 1, that you can decide, okay, I am at this place, what is the minimum cost to reach n? It will behave like starting at a particular index using form 2 only. So it is more naturally a form 2 rather than form 1. If you go through the transitions I plus 1, I plus 2, I plus k, so on, okay, that is form 2 itself. One other way would be you can keep track of where was the last place you hit and you are moving forward, but that would be more inefficient. You can do it with form 1, but this is a more natural choice for form 2. So form 2 comes in action when you have a problem where there is subsequence getting formed. Clear, everyone? So minimum cost to reach level from 1. That's what we can keep over here. Is this clear to everyone? Quick +1 if this is making sense. Why did we keep this and how did this came into action? Okay. If you guys don't remember what forms are, I'm already giving you. This is like, this comes from form itself. So if in case you have not yet covered forms, this is where forms comes into action. Okay. I don't, that in some question we calculate total cost by adding or bringing with recursion result returned by subproblem, while some requires keep cost so far as a state. Yeah, you can do that. So whatever, so it is both an option, right? This return type can also be a parameter and you return a void thing, right? What actually, like, I should tell this to you, what actually is happening is you are having a void, some recurrence, some bunch of things, and the answer over here as well, like some other parameter over here as well. Now you decide which one do you want to return and you want to calculate it using the rest. So it's actually, it's fine if you keep something over here as well and then you rotate things up. I mean, that's perfectly fine. You don't get to don't get to decide, use the natural senses, right? That's what I'm saying. When you see subsequence, when you see jumps, when you see paths, form 2 is the natural choice. When you see, we're gonna solve more problems, right? So you're gonna get more and more idea as you see more and more problems. So when you see this, so try to visualize how the jumping is happening, and if it seems like a subsequence, it's a form 2 problem. Okay. So this is the state. I am going to quickly go through the transition. It's very easy. Okay. How do you go through transitions? So it is a very standard thing for form 2 problems. How do we write the transition? So let's say you have to reach at this place, right? This is the level. Now the last jump could have been made from this or till some place like this, like level. You could have you could have been at level -1 and you could have made a jump of 1, or you could have been at level -2 and you could have made a jump of 2, or you could have been up till level -k and you could have made a jump of k. So from these places you can come to this level with an immediate jump. Note that how does form 2 work? It counts the immediate jumps that happens in the subsequence, okay, or the last move that happens such that this element was added. So from that we can write the transition very simply as dp of level would be equal to min across all, okay, across all different things, dp of level minus some x. You could, let's say this x is gonna range in the range k till 1, okay. You can go back k steps provided it is a valid state, right? It is not going beyond this point 1, and plus abs of the h of level minus x minus h of level. That's the cost of this jump. So if you're jumping from some level minus x, this jump, what is the best way to reach this? And then this jump is going to cost you abs of difference of, let's say, dp of level minus x minus dp of level, and so on. That's the whole thing. Okay. Is k equal to level -1? No, that's not level -1. K can be level -1, but I mean, on the worst case, it could be till level -1, but x can be up till k. So you can come to this particular state from level -1, level -2 up till level -k. You can come from these different states, right? The last immediate jump would be like that, because in the problem you are given that you can only jump k steps. That's the setup in the problem. You can only jump k steps. Clear? That's almost the whole thing that is there for this particular problem. Yes, that is true. I got your point. So yeah, I mean that comes with, to some sense, with practice. But generally, if the values are larger, like in this case, the absolute summation could be bigger. So we are adding it in the answer. Whatever is the biggest thing that you have to keep track of is what you return in general. So it depends upon the constraints actually. What do you want to return and all? Okay. So that's there. Yeah. So you could, so in that case, like you can jump from, that is correct, Abhi. Like what you're suggesting is also possible, like based on that, like we are looping over here from where you can come, right? So just loop over all the places where you can come from. That is a simple thing with that way. Okay, so in that case you can loop over the previous states which are like of the same parity, or of a different parity than level. Okay, so in that case you can go in an off and transition, but we can solve this in other way as well, right? I mean, for now this is the problem, but yeah, exactly. Okay, so this is the transition. quick. Now you guys, now up to you guys. Tell me quickly what will be the time complexity for this one using the formula that we know. How do we find out time complexity? What is the number of states and number of transitions? What is the number of states and number of transitions? Tell me this real quick. So for every level can be till n different values. So states are n, okay, and for each n you can at most have k different transitions. So the transitions is k. So order n into k. No, Shoma, why is it n into k square? States are only n, right? And transition is k. So we use the formula that we know, number of states into 1 plus number of transitions. Okay. The cost to calculate the transitions and stuff is all order 1. So it doesn't really add anything over here. So it is this. Okay, so this is the thing. So Kurmudi is saying that when I'm using coins option, we will do CSS as well. Don't worry, I'm gonna give you guys everything. Like CSS is also something that I'm gonna cover for you guys. Okay, CSS we will cover, but in that we will mostly use iterative coding. So for today, what we are doing is we're gonna use recursive coding to most sense to solve the problems. But when we solve CSS, we will do iterative, because in the day 5 I've already like uploaded the videos, and in that I have mentioned that why iterative codings are sometimes better, and how to convert these recursive modeling into an iterative code by just thinking about the order of loops. Okay, so in that case you will be able to cover with both of the things. So we will cover CSS with iterative coding. Okay, that is specifically because CSS has a higher constraint, like 10 to the power 8, and recursive codes, when you when every state can be visited in the same recursion, 10 to the power 8 happens to be a very big number for a stack, for the stack to keep track of together. So that's why we sometimes get runtime errors for for those cases when you write recursive codes, right? And that's why we're gonna go for iterative coding. Okay. Sounds good to everyone? Do we need to code this problem? Yes or no? How to find if all states are visited? Okay, nope. I can see. So most of the people will say no, because we have coded much harder problems than this. Than this problem, right? So I think we can skip the coding for this problem at least. Maybe I will show you the one where we maybe generate solution, the F problem, right? We have solved much harder problems than this in the video. So if you have seen the workshop videos, I think this problem is the most easiest problem that you can kind of go through, right? And then next ones we can kind of do through more and more problems. But yeah, I'm stuck in mth question. Mth question you can do after watching the day 6 of the workshop. I'm gonna upload the day 6 soon enough. Because I wanted you guys to go through this Atcoder one first and then go through day 6. I'm going to upload the day 6, and then after that you can solve the M problem too very easily. Okay. There's a small optimization involved in that one, so that's why it's difficult to solve that one in an optimal way. Okay, so once this is done, let's move to the next problem then. Let's move to the next one. So next one is going to be C. So if we are going with C, let's open up C over here. You guys can see the problem C, right? Okay. How many of you are able to understand which form this might be in? Like, you can read the problem and then you can tell me which form this problem seems to be in. Join late with brother's account. Okay, no problem. It's actually really good to see that people are interested in joining in such educational sessions, because I had more inclined to. I thought maybe people only join still streams, but okay, people are interested in learning, so I will teach more. Form 1, Form 2. Okay. Oh, Hindu Rashtra. Okay, nice. Chalo. Form 2, Form 1. Okay. So over here, this seems like a more of a natural choice for Form 1. I understand that Form 1 and Form 2 is the most confusing and closest thing. You can actually solve this problem with Form 2 as well, Form 2 as well, but we will use Form 1. Reason being, over here you can place A, B and C, right? What is this choice that we follow over here? Over here we are deciding then on this day I will do A or B or C. Okay, I will do A or B or C. Okay, I will do A or B or C, but there is a small restriction that on the 2 consecutive days you cannot do the same thing, right? That's the only restriction. So we are dealing with form 1 over here, because on each day you have to decide what type you have to do, take or not take, A, B, C or not, and so on. Okay, and in that case you can keep track of what we had done in the previous case. So we will use form 1, we will write dp of level. So when you say form 1, it's like this is level and you have decided what you take over here. And to decide over here whether you can take A or B or C, you need to know which one did you decide over here. So what was the last one you took? Last. Okay, this can be either A or B or C, encoded equivalently into 0, 1 and 2. Let's say, okay, we're gonna keep a number. So A is like 0, B is like 1, C is like 2. So which one did you take last? Yeah, so Abhi is saying if you know the form, you know the solution. If this is the case, what's the problem in exploring all 5 options in a problem? Okay, if you know that if you know the form, if you know the form, you can solve the problem. Go ahead and explore all the 5 options, which form it can fit in. And most probably, if you eliminate problems properly, in general, like every problem can be either 1 or 2 forms. Okay, so explore both the directions. Okay, if whatever works works. Like it cannot be easier than that, right? I just made it infinite possibility to 5 different possibilities for most of the medium level, easy to medium level problems. So now you can like just think about those 5 forms and do it, right? So this is the case. Yeah, that makes sense. So over here we have level last. This is what we keep. So in order to, so remember this, if you ever have an interaction that you cannot take whatever is in the previous element, or depending upon the previous element, keep track of what is the previous element. We have solved similar problem in the workshop 0, 1, 0, 0. To keep track of what we can take over here, we kept track of last 3 items, right? So over here also you can keep track of this. Now over here there is a small caveat. Okay, I'm gonna explain what that is, but towards the coding, this is the state part. Okay, transitions, it's very easy. Dp of, if you have some level comma, let's say 0, you can go to dp of, you can put a 1 over here or 2 over here. So level comma 1. What is the problem? Let me just quickly go back and see it once. What is the maximum possible total value? And on each day you are given ai point, right? So you can do 1 plus a of b of I. So if you take b over here, or over here if you take, this is level plus 1, or if you take c, then you are gonna have for the next item, the last item taken would be 2. Okay, and then this would be getting a plus ci value, whatever c level. When I say I, it's level only, L. Okay, so out of these, whichever is going to give you the maximum score as per the problem is what is going to be the answer. Okay, you have to find the maximum possible total points. So whatever is going to give us the maximum is going to be the 0. So this is for 0. Okay, so similarly for 1, we can go to, like, just copy paste this same thing, and this would be 0 and this would be 2, right? And we take the max across the 2. Again, if you see the transition for the next thing, for 2 we can go into 1 and 0. Sorry, this should change. This should be a over here, a of L, and this should be 0, so this should be a, this should be 1, so this should be b. Yes, that's the caveat. What to take in start? That's a very good question. That's a very good question. And in fact, Shaurya has already answered that itself. Right, iterative will be easy to write in this case. It seems it's easy, but yeah, I mean, we can write recursive also. It never works. It is easy in that case too. I mean, it's not easy and difficult that happens to be in the case. Most of the way, I personally feel recursives are generally easy on an average, provided that you don't have to do any optimization on top of it. Okay, Okay. Yes, we will do that. We will do that. Don't worry. So this is the case. This is the solution that we will keep. I guess you guys have already understood what will be the time complexity. What will be the time complexity for this one? Number of states, number of transitions. Very, very simple. Optimal substructure and overlapping subproblem. I get confused in these two terms. Quick off the topic discussion. So there are two terms that you might like hear a lot of time: optimal substructure, okay, and overlapping subproblem. Okay, well, these are theoretical terms, and at times I personally feel that when you go to a higher level of difficulty, you don't really think about these things anymore, but this do happen. What optimal substructure actually, like in its true sense, talks about is that the dependency is a DAG. Okay, to some degree it talks about dependency being a DAG. Okay, DAG means there is a, like, you only go for smaller substructures. Like, sub means smaller. Okay, and this optimal over here in this means that, let's say, some dp of x depends upon dp of some similar state y and dp of similar state z. So first of all, this y and z should be smaller problems of the original problem. So a sub over here in the term. Optimal means whatever is the optimal solution over here and over here should be merged to get the optimal solution over here, not any other solutions. Like, the best you can do over here is what will lead to best doing over here, right? In fact, let's go back over here. The best you can do, so the best you can do post this much, like in the level plus 1 in forward, is what is going to give you the answer for dp of level, right? The best you can do from level plus 1. So if you merge the bests to get the best, then that is what is called optimal substructure property. Okay, what is overlapping substructure? So let's say we call, like, if you can think about rod cutting problem, right? dp of, let's say, 1 to n. So in that case we can, like, sometimes you can, let's say some other problem, let's say you can delete one element from both the sides, something like that. So in that case we can go to dp of, let's say, 2 comma n, or we can also go to dp of 1 comma n minus 1. Then from over here we can try and eliminate from two sides. Two options would be there, but there would be one state which is common, dp of 2 comma n minus 1. So this state is possible through this track and this track also. So optimal substructure means a substructure is actually being repeated. Okay, and over here, if this particular this particular state is computed only once, it will actually save us something, right? In certain brute force problems, we don't really get any benefit in case you cache. Okay, in case you save the values, you don't get any benefit because that state never gets repeated, like n queen's problem. Okay, but in these cases sometimes we get a lot of benefits because these states do get repeated. In that case, caching makes sense. So we only cache when we have repeating things, and we can merge optimals of smaller subproblems to get the bigger problem optimal solution. So that's what optimal substructure means. So these are two key terms that you generally see in theoretical DP, but I would say we are way past these levels now. It's mostly about applying them in problems. But yeah, definitely understand the meaning of these terms, right? Is the terms clear to everyone? Like, I mean, it's important to actually know them theoretically as well, right? God level clarity aa gaya kya? You guys got God level clarity after this? Okay. Great. Chalo, let's move on then to the problem that we are solving. I wish I could teach you guys every day. Like, I think it would take me 3-4 months to make you guys expert. So level this 3, there are 3 choices over here. This can take 3 different options. This can take n different options. So 3n over here. And number of transitions, for each state you have 2 transitions. So 2 transitions. So order of 3n into 1 plus 2, which is going to be order 9n, but order n actually. I mean, never use the intermediate, like never use 9n to check. Okay, always use the final time complexity to check whether it will pass or not. Order n will pass, so yes, we can use it. Okay. Okay, that's correct. Oh, finally Dhruvastrah back with his own account. Nice. Okay, so now that's the time complexity. Now there is one very like, I mean, coding this is very simple. Like it would hardly take me like any time to code this one. But tell me, what is going to be the start call that you make? What is going to be the start call that you make? What is going to be the base call that you make so that this solves it correctly? Tell me this, and I think you guys have understood the whole idea. हंसते तो नहीं है, don't worry. I understand the point of view even from your side. I like, when I teach, I generally understand the perspective of the students too, like where they can understand which topics, which parts you might be finding difficult. Like in this said, I directly wrote the true transitions. Sometimes if you're new, you might find it difficult. How did I write the true transitions? I understand where like some issues can happen, though with the time restriction, I cannot explain each and every one of it. My bad, but can't explain each and every line. But I think we have discussed a lot of questions this. Okay. So what is the base case? If simple index or level, we kept a level, so let's keep level, right? If level is equal to n, then we are done and we cannot get any more score, so we will return 0. And we have bunch of like integer n, integer a, b. So why do I write 100 100? So sometimes like when you write array, right, sometimes you might miss a 0 and then it might be one space smaller. So 100 100 I know is of 10 to the power 5. So that's how I remember things, like so that I don't make a typo, right? Because while typing zeros you can make a mistake, right? You might omit 10 and then it will get wrong answer. So it will get runtime error. So that's why I write 100 100 sometimes in code, if you were wondering why I do that. Next is if base case is equal to 0, because little extra space doesn't really cost us anything, right? Save and compute. What is this? Cache check. Okay, so what is the main thing that we're gonna call? Form 1 with previous elements. Yeah, that is correct. So we are using form 1 with previous element. What is the thing that we like? What do we call over here to get the like answer? Tell me this. Right. Everybody knows how to make a template in Sublime Text. Okay, you guys can Google at least, right? The main thing is that when you're calling recurrence, we're gonna call recurrence of 1 like 0. We need to start at 0, but for 0 nothing was last, right? So you didn't have really anything over here. Okay. So one thing you can do is you can keep, let's say, -1 over here if you want. That is one option. Okay, I'm gonna give you one option in this case. And the way we can handle this is integer answer equal to 0 for we need to get the maximum, right? So 0 should be fine. For integer I equal to 0, I is less than 2, I is less than 3, I plus plus. These are my options. Which are options are there? If I is not equal to last, then we can use that one over here. So over here, a very neat thing that you can do is you can keep a cost, and you can keep 3 different arrays over here. So cost of 0 comma this would mean you are at A array. Cost of 1 comma like anything will mean B arrays. 2 comma thing will mean 3 arrays, so that you can use this loop over here itself. So answer equal to max of answer comma dp of level plus 1, and you have used this I as the current element, plus whatever at this index you can get with this current element. So that would be cost of I at this index level. That is what we can keep over here as the max. Okay, but when we cache and save, what we were doing, we were return dp of level comma last equal to answer. Okay, Same thing we were doing over here also. If dp is this not equal to this, but if we have -1, this will be an error, right? The last will be negative. Like this all parts will work correctly. These all parts, this all is good. But when you save in an array, it will be problem. So how to rectify this one? Last plus one, but that will save it at 0, right? That is not the correct meaning of things. Offset, we have learned that in one of the videos. That's correct. Offset is one of the good ideas. There is one very, very interesting idea too. Okay. No done and all, like because the index itself is negative. If last equal to -1, return answer. What did I just do of all of this? So for the first call that happens, level comma last, okay, over here also, if last is not equal to -1 and dp of level comma last is not equal to -1 as well. So we are saving and retrieving only when last is not equal to -1. Last is going to be -1 only for the first call. So we don't save and cache it. That's fine enough with us, right? Okay, that's correct. Sure, that's the next solution. That's the more elegant solution. This is a like small code tweak that I wanted to teach you guys so that you can also use this at times if required. That sometimes only for one state your parameter seems to be very, very non-conformant with the type of like structure that you're keeping, so that you can save it in a data structure or in a DP array, right? So in that case, simply don't save it and handle it like an exception that, okay, I'm not caching this one call. Every time this call happens, it will compute it, but for the rest of the states, it's all saved. So it's going to be just order 3 call. Okay. Yeah, exactly. The other way that you can do this is like, this is the first way to do this. This is a very this is the much neater way. The other thing that we can do over here is not really write these things over here. This is like kind of breaking the rule that we had for coding. So what we do is we find out the meaning much better way. So we print out, cout. What if we take the first element as a? So in that case, we're gonna get d. So we're gonna go to dp of 1, 0. First element is a plus cost of 0, let's say 0 for the first element. We are doing this. Okay. We'll take max across all the 3. So we can call these also. This is also fine because you loop over the first 3 iterations, that which 3 we want to take the maximum across, and then like go to the next step of the DP directly, and that is like one of the possible states. Like if you take the first element as 0, then this is the DP state that gets called plus this cost, and this is the DP state that gets called with the cost, and this is the DP state with, sorry, this is going to be 2, and this is going to be 2 as well. This is the DP state that gets called, and so on, right? Great. Clear everyone how to handle these like small cases of like first call being exceptional in such cases? Clear to everyone? Quick +1 if you guys have understood this one. I hope this made some sense. The more you clearly understand these things, right, the more competence around DP will grow. Okay. No, we don't really like. So see what. So someone has asked me this simple question that when do we need to flush the DP array? I mean, we need to flush the DP array obviously. Like at the start, we need to DP memset DP -1 size of DP. That needs to happen at the start before the call, and we need to take the inputs. Take input to over here. But the main thing that I want to talk about is when do you need to flush array? So whenever something, so this DP array depends upon number 1 the cost array, number 2 the n. Okay, so if n or the cost array changes, you will have to flush the DP array. Very simply, if you're thinking about when do we need to flush the DP array and recompute things, if anything that you have used in the code inside the inside the recurrence changes, cost array, n is used as a base case. So if any of the two changes, you have to refresh, or else you don't need to. This is also something I've discussed in one of the caching across the state problem, right? Caching across test cases. Okay, so that's the code even for this problem. Let's move on to the next one. I think next one is one of the most asked problems because people find it difficult to print solutions. Find the longest string that is subsequence of both entries. So it is LCS with printing. Okay. Let me go back once. Yeah. By the way, just an offshoot question. Did you guys participate in Hacker Cup? No, that will not be possible. That is wrong. Sorry, but fine. It's perfectly fine. Yes. So leave after solving two problems. Yeah, I mean, for like qualification round doesn't make sense. I also solved only one problem, so it doesn't really make sense. I just made a submission yesterday itself, like at night, one question. But I can discuss that one problem for you guys. Like I solved only the D problem, just to make sure that I get things like that qualified. So I solved only D. If you guys have already solved it, then I don't know. But I can discuss that if required in some of the video. Okay. So that is there. So you guys could solve C. How many of you had solved C question? Let's not discuss it in this video. Okay, first time solving Hacker Cup. That's great. Okay, I think the editorials are anyways out, so you can read them. Okay, sure. No college. I mean, personally, I would have like prioritized this over college, but I understand it's difficult to manage. Okay, let's come back. LCS. We have solved LCS in the videos, yes or no? That's great, Harsh. B2 problem is good. Makes sense. Yes. So to be very honest, I have not read ABC. Okay, but I just know the expected difficulty of those problems. I just read D just so that because for me at least solving just D makes sense. Like I have already solved. Like I think I can. I hope I can solve ABC. So I just solved D at the last moment. Okay, let's go through this problem real quick. We have to find the LCS, printing one, right? How do we print solutions? Remember everyone? So very simply, recurrence of. So let's say I'm not going to write the code now. Like you are given string A and B and like n and m is the length. We had written this code, right? What is the LCS of A of I till n minus 1 and B of j till m minus 1. This is something we had already written. Remember this? Okay, so now we're gonna write only the function which is gonna print the solution. I think some of you were asking me that Vivek, I'm not able to print it. I was not sure why, but I think we can solve these things even with like the things that we had learned, right? Void print solution. Okay, so let's say you have to print string solution string, like solution string over here. We are building this. Okay, print solution. So the way we do it is like we call the recurrence, like int LCS is equal to the length of the LCS would be recurrence of let's say 0, 0, and that will give me the recurrence of LCS of the whole strings. Okay, now if you have to print, we will call print solution from 0, 0, start with the state integer I, j. Okay, this is a form. Which form this is? Form 3, right? Everybody remembers form 3. This is something we have discussed. I'm not repeating the code over here. Okay, but this is a form 3 problem. When I print solution, very simply, there are three transitions: either omit in A, omit in B, or take it as a common. Okay. If recurrence, so now what we will do is we will simply check if I is equal to n or j is equal to m. We are done. Return. Okay, because we are not going to get any new characters. If recurrence of I comma j, okay, is equal to recurrence of I, so these are the different transitions, I plus 1 comma j. Okay, in that case it's saying omit. So if the current true value, like the potential value over here, is same as the I plus 1 comma j, so then it would have got its value over from this one. So we need to print solutions going through this state. Note that these all calls will work like order 1 calls, right, because they are being cached. If none of them are true, then obviously this must have got its value from I plus 1, like, or else this should be true, or else this should be true. These are the only three transitions that we took. Out of them only we took the max. So if this is equal to this, then we know that we took this current character plus 1 and then we found out the best over here. So solution plus equals to the current character at A. So A of what is the character? A of the position at I, and then we print solution I plus 1 j plus 1. Go forward and find out the next characters. So this will finally build me the solution in the solution string. You can print the characters one by one over here itself, but this is what we can do as well. So find out which transition led to the true value of recurrence at I comma j, okay, and use that transition to generate further. If that transition meant taking this character into the LCS, print it into the solution. I mean, you can print it then and there itself, or I'm just saving it in the solution string and we are printing it afterwards after that, right? So this is the whole solution for this one. Clear everyone how to print the solution over here for this problem? This is a direct form 3 application and we have solved this problem already in the videos itself. Yeah, we did printing problems, but just for LCS, a few people were telling me that you are unable to think, so I just thought about just printing this one. So in case we omit the first character, what was the recurrence that we were writing, right? The value at I comma j was equal to max of this, and in case the characters are same, then this. But if the maximum turned out to be this, then what we meant? We meant that it is optimal to omit the character from A. So in that case, we omit and print from this. How do you get the best answer? If this is equal to this, if the optimal answer over here is equal to this, which means the first character at A makes no sense. We will get the same answer even if we go to this particular state. So go there and find out solutions from thereafter. That's what this means, okay? Is it clear, Avi? How did this work? If it doesn't change my value, if it's okay to omit the character, then omit it and print from the rest of the things, like what is the best that you can get after that. Okay, revise the printing solutions video once if you are not sure about this one. I think something similar we already did before. Okay, cool. Let's go to the next problem. Let's move to the next one. So let's talk about G next, okay, which is the longest path. Okay, so in this case we are given a graph. So before taking this problem, I assume that you know basics of graph and how to store graphs and stuff. I have not taught graph before, but I assume that you guys might know some basic stuff. Okay. So Shad is kind of like recommending one interesting TMS problem. You can check this out. I have not seen this one. Yeah, that is correct, Abhi. But like there are three, right? So we have to find out which one best led to the solution. Yeah, that is true. That is correct. Three videos are hidden. I mean, I think they were removed. The videos were removed later, I think. So you should get all the things in the playlist. Don't worry. So over here, you have 1, 2, n for each I. Directed edge goes from xi to y, x to y. G doesn't contain directed cycles. Okay, so that is also very simple. So in this case, how do we solve the problem? How do we solve the problem for this graph? So no need of topo sorting. So people who are saying that this requires topological sorting, no need. If you're using DP, you are already doing topological sorting by its name. No need of any BFS DFS. This is not a BFS DFS problem. This is a DP problem. I'm going to show you how to solve this problem without any graph logic. Okay, let's learn this. Okay, let's learn this. So I have seen many people typing in topological ordering and then typing in DP on top of it. Okay. So I'm gonna do it without this. So the question says that we have to find the longest directed path in G. That's the question itself. So I'm not gonna be explaining graph today because I assume that this is like directly over there. But longest path. Have we solved path before? Which form does path problems lies in? Generally, there are obviously exceptions, okay? But which state does path problems lies in? Which form? Real quick, form 2, right? So we need to find out in a graph what is the longest path. So longest path has to start or end somewhere, okay? So what we can do is, we can do, let's say form 2, but in a way that what is the longest path starting from this place. So let me just quickly go through this particular whole problem itself. So we know that we save vectors of, let's say, integer in array in G. Let's say the graph is going to be stored like this, right? Something like this. This is how we store graphs, right? And integer n and m, the number of nodes and number of edges is generally given to us. So we are given seeing n, m for all the edges for integer I equal to 0, I is less than m, I plus plus. We need to see, we are given an edge, it's a directed edge. So we need to put in the G of A dot push back B. So it's a directed edge, so we don't put the reverse way, okay? This is a form 1 problem. So this is how we take the input. Now we can try and find out. We'll write integer recurrence, integer x, okay? It's gonna tell me what is the longest path starting at x. So starting at x or ending at x, these are both form 2, okay? From x till end, I mean starting at a node or ending at an index or node is the same thing, okay? So I'm just doing this way because we have the transitions for forward direction, like we have saved from A where you can go. So we have the saved transitions from this, okay? So in this case, what we will do is, what is the longest path starting at this index x? So we will use the same thing. Pruning, there is nothing. Base case, there is nothing in directly, like as a base case. So integer answer is equal to 1, like we have only one node. Let me just quickly check if you are counting the edges or the nodes. So in this case the answer is 3, so we are counting edges. So base case would be 0 to certain sense, okay? So answer is by default 0, okay? This is the base case also, and this is like if there is no neighbor, then this is the base case. Auto V in G of x, it's like going into the neighbors, right? Answer equal to max of answer comma, you can take this edge 1 plus whatever best you can do from that particular node, okay? And then return answer. तो फिर हर नोड से yeah, right. Okay, go to adjacent S and make max of neighbor. Yeah, that's correct. So answer of 0, V of G of x is this. This is the like recurrence answer with max of this, and we obviously need to memorize this one. So I'm gonna write this DP as well. By default, the paths can never be negative, so I'm gonna do memset DP minus 1 size of DP. Okay, and then we're gonna like use this DP array directly. So if DP of x is not equal to minus 1, then we know the answer, so we return the DP value, or else we are gonna be saving it up, right? So this is how we do it, and in fact that's the whole code. This is gonna find you the best like starting, like, so whatever like longest path that starts over here will go to one of the nodes, right? So across all, go to that node and then find out the best longest path. That's what this recurrence is going to return from there, and we're going to get the best one over here, okay? So over here we wrote this particular DP, and now if you just simply go ahead and integer answer equal to final answer equal to 0 for integer I equal to, we go through all the node, all the nodes answer, like final answer is equal to max of final answer comma recurrence of I, longest path and starting from there, cout final answer. That should be all. That should be all. If you are using DP on so topological ordering comes naturally for such problems, but DP in its recursive sense, note this very carefully, DP in its recursive sense takes care of all topological ordering and all. If you have to write iterative code, then you need to know the order in which you have to process the nodes, or the process the states. In that case, to know that order, you have to find out topological ordering. But if you are writing recursive code, there is no need to resolve into dependency of ordering of the states in which you should solve the problem. Right? Yeah, I mean, you can say this is a DFS, but it's actually DP only, but it's recursively finding the best solution directly. This works for any graph? No, it will not work for any graph. It has to be a DAG. Like even topological ordering works for only DAGs only. So we can find the longest path only for DAGs. DAGs means directed acyclic graph. Okay. So in that case, you can only use for that. But this is a very simple code, right? Why to get into that like different sorts of topological ordering algorithm and then finally again doing the same thing? Why to do that? If you can just write this simple code and do it. Right? I see so many people doing it twice. G of A dot pushback B means it is like A has a neighbor B. That's what we are saving over here. Sorry, I forgot to take the input over here. But this is how we do it. Clear everyone? Quick plus one if this makes sense to everyone. If this is clear, this is how you find the DAG for the graph. Let's check if it's working fine. What is this? Oh, this is the other problem. That's what I'm thinking. Like, how did the problem change with the linear input? Right over here we have something like this. Let's check quickly. Clear? It gives us 3 value that is there. Okay, no problem. So this is the problem for this one. Let's move ahead. Why are we looping for every node? Because we have to loop over all the neighbors, right? Because the maximum can be from any one of them. So that's the transition. What is the time complexity of this code? N into N. Okay. V plus E. That's correct. It's actually V plus E. This is the first time where we are dealing with average number of transitions problem. This is the first case where we deal with average number of transitions with the problem. Okay. So let's go back to like the time complexity formula that we had and try to see how to solve this one. So you wrote recurrence of a node. Okay. And for that, for all neighbors, there is a transition. So for each node, you have the number of transition equivalent to its degree. Okay. So number of states is N. But number of transitions for each state on the worst case is going to be order n. Okay. But on average, it is going to be number of edges divided by n, because you are looping over the degrees and each edge can be only in one of the nodes. So m by n. So that's why when you have to use the average number of transitions in each state. So over here we plug the formula n into 1 plus m by n, which gives you order n plus m. Can you make us understand a red level problem any day? Sure, I can take up a red level problem and make it so easy that you would find why is it a red level problem. But this is how we analyze the time complexity for this. So always use average in case it's unequal. Don't just put n into n. Okay, that's wrong. In fact, it's known that DFS and BFS works in V plus E or n plus m. This is the reason why it works that way. Clear? Great. Yeah, that's what is the goal, right? This workshop is actually to try to transfer the weights of the neural networks into your brains as much as possible. Okay, 217. Everything will. So you guys will see, right? Once we solve a lot of problems, you will see that you are going to recognize problems very, very easily of DP. Don't worry. Okay. So now I'm gonna like quickly skim past some of the problems which we have already discussed. This one, I think we have discussed this already in the videos, and it's also on the platform that I have shared, like the questions, practice problems that I have shared. So I'm gonna skip this problem, but I hope you guys will be able to solve this one, right? We have discussed very similar problem, and we have the same problem in the platform too. So I'm gonna skip this one. Okay. So all the other DP problems that I have covered, maybe I will add them below the playlist also in the DP workshop. Okay. Or maybe I will create another playlist called all DP problems, all DP concepts, and create a playlist out of that. Okay, should I skip this one? Should we move to the next problem? Everybody will be able to code this one? Quick +1 if you guys are able to do that. We'll move to the next one then. Cool. Let's move to the next one. This is very simple, not that hard. Just make sure that you handle things correctly. Lead code, burst balloon, yeah, these are like very, very standard and simple problems. Scramble string, burst balloon, these are good LRDP problems. Then you can solve them, that's not a problem. I mean, there are many problems. Where should I learn DSA? So, like in general, I would say that if you have time and if you have the willpower, then I think you should not go for any training, like paid training that somebody suggested Algorithm. Even though I teach at Algorithm, I'm not saying that if you have the willpower and if you have time, don't go for any paid training. Like just go through problems, contest, and learn things. That's how even I did. But like one good paid training would be Algorithm, because that like they are also the sponsor for this workshop, and like even I teach there, so I can vouch for the quality of the content. It's very, very top notch. Like it's not an average training, it's a hard training, but if you go through that training, I have seen people coming out with very, very like strong skills in all the DSA topics. Very strong skills. And it's a challenging training. Like it's a very challenging training. You can say flying colors. I mean, like you can see that like that is also there. Like the results are very, very good in Algorithm, because most of like even like tier 1 college students, like you can think about all, like most of IITians also like prepare from Algorithm itself. So that is also one thing. Even people like the more you put in time, the more you benefit. It's not like anything dependent on college, which college you are in, but many people who are even in top tier colleges are also preparing at Algorithm. So that's there. Into maybe question story ki tarah para. So they have stories, like at least when I ask, I give story. So that's there. Are these live? Yeah, I take the live classes. Yeah. So there are 2 live classes per week. Mostly I take them. 301 running anytime soon? No, not yet. It's not decided. Mostly in winters, and it's not going to be accessible without AZ 201. Mostly that's going to be there. And 301 would be free if it runs, but it's going to be for selected students for top performance from AZ 201. That's how it's going to be there. Is the content same as 29? No. The content has like changed like drastically. Like it has at least tripled the number of content, because every batch I teach new things, right? Every batch I take new problems and add the older ones as videos and teach new problems. So the more you, it has tripled at least. Yeah, these are all good questions. Okay, let's go back and like kind of go through these problems. We have this coin problem, very, very simple. I'm going to quickly go through the formulation. Which form does this problem lie in? Coupons, I don't think there is any coupon running right now. I think if you see their Facebook page, you will get certain coupons at some days, but I don't think any coupon is running right now. Mostly you can use referral codes. If anybody who is a student at AZ you can post your referral code over here in the chat, and maybe you will get some referral bonuses. But yeah, there is a referral code that happens to be there in Algorithm. Okay, let's come back. Let's not talk about Algorithm today. We're talking about Atcoder contest questions. So we have n coins numbered 1 to n. For each coin I, we have a probability pi that it comes with heads or tails. Taro has all n coins. Find the probability of having more heads than tails. Okay. Yeah, on each side, 500 on each side. That makes sense. So if you refer, you get 500, and somebody who takes the referral also gets a 500 cashback, both of them. Form 5? How is it form 5? Is this a game? No. Form 1 makes more sense. It's a form 1, right? The simple form 1, for each position we have to decide, for each position we are at, we have to decide whether it will be a heads or a tails, right? So we can keep track of this dp of level which we are at, and to decide at the end whether we are at a valid configuration, we can keep track of how many heads we had. Okay, heads till now, because at the end the number of heads has to be greater than equal to tails or something like that, whatever is mentioned in the problem. More heads than tails, so heads has to be greater than tails at the end. Okay, so you go through each index. So for these you have decided that this is, let's say, heads, this is, let's say, tail, and you are over here, so you will be at dp of, let's say, index 2, and you have decided to take one head till now. What is the probability of getting, so what is the question? Probability like of getting more heads than tails. The same thing, but for this much of the problem. Okay. Okay, it's a probability bus, but it's a form 1 question. Don't get biased by that. Yeah. So over here we can keep track of transitions too, very simply. So dp of, let's say, L plus with x number of heads. Over here, if you try to take a head, then you are gonna go to dp of L plus 1 comma x plus 1, but you will have a probability of pi of whatever things happening on this branch, so you multiply it with p of I, and 1 minus p of I of having a tail multiplied by whatever happens over here. So all the things, so the way I see probability is, if you go into a branch and that branch has a probability p of I, then whatever happens on that branch will get multiplied with p of I, because that's the probability of that branch happening. So you multiply that. Okay, dp of L plus 1 with tail increasing, and you have this at the end. Okay, if level equal to n, return 1. No, that's not correct. That's not correct. It's not a fair coin. Every coin has its own probability, so it is given in the problem. So it's not 0.5, but and at level equal to n, we need to check if the final x is bigger than n minus x, because you had made n tosses. Number of heads is x, number of tails is n minus x, because if it is not heads, then it's a tail. So if x is greater than n minus x, then you return 1, because then it's a valid path that you have taken. Is that clear? Hindu Rashtra, batao, is that clear? Not level equal to n, return 1. That is a base case, but in that case you have to check if it is a valid configuration, right? So then only we do this way. Clear, everyone? How did this work? Yeah, that will form total number. Exactly, it will give you like 1. It will give you as a result 1. Actually, if you do it, just return 1 and over there. You have to find out probability, right? So that's the whole thing. That's the whole way to solve this problem. If you know the transition, if you know the base case, if you know the states, then you can write the code very easily now. Not at all hard. The only small caveat is we are returning a floating point value now. Okay, we are returning a floating point value. So check out the triangulation problem on day 5, part 3. That problem contained returning a floating point too, and you can see how to cache the values from that video. You will learn that. And you can use the same thing over here as well. Okay, you can maintain a done array or a visited array. Yeah, that makes sense. Yeah, so simply calculate total number of ways of head greater than tail and divide it by answer this. Yeah, it's actually true. The answer is nothing but, yeah, you can do it that way. You can do it that way, but in that case the numerator, so when you're dividing it by 2 to the power n, the numerator itself is very large number. This is also very large number, so it will get into a lot of precision errors. So instead, keep it in the path itself where you are multiplying the numbers 1 by 1, because then it will be correct, much more correct. Okay, don't let division pile up when you are using floating point things. Okay, can we check in between what will be pi? Probability of I is given in the problem, right? You cannot, right? Yeah. P of I is given, right? When ith con tosses, it comes up like ith coin will get heads with a probability p of I, and ith coin will give a tails with a probability 1 minus p of I. So every coin is different, so you cannot use it directly like a formula. I think that is something you have missed up. Sorry, right? Okay, so that's how you solve this particular problem very, very simply. I mean, we are actually iterating over all these possibilities and we are multiplying the things accordingly if it's feasible at the end, if the count is feasible. Okay. Clear, everyone? Can I have a quick plus one from everyone who is like right now on the stream, just to see if you guys are clear on this particular problem. This is the one of the most like interesting form 1 problem in DP Atcoder contest that you can get, because it's using floating point also. So it will give you some practice on that. Great. So many people are there for like 1 hour now. So you guys have patience. I was into an impression that YouTube doesn't really have patience and you need to build content which has to be very flashy to retain audience. That is something I feel is true for YouTube. At least I know that for sure. Like ideally, if I make a content which is very, very flashy, it will make more reach. But again, and it turns out that making non-flashy content is a very nice way to filter out people who are really interested. But again, when you are doing YouTube, then you need to have some content like that to get reach, because I personally feel that not a lot of people would know about this channel also if you don't create any content like that. That is what somebody suggested me. That one person said me, I think like I was in an impression that I will not make any content which is like high reach generic content, but some people suggested me that actually I should make them, because from that only people will come to know about the channel, or else people are not able to know about the channel itself on the first glance itself. Okay. So maybe I will make some with, let's say, things like how to make crores of package in India, because I've trained few people, like few folks I have trained in algorithms like have CTC more than 1 crore in India. So like there is one is how do you make 1 CR? There are 2 ways. One is going abroad and one is staying in India and still making 1 CR. How to do that? That would be really interesting. So these are high reach content. You guys can say, right, this is high reach because this immediately needs to this. Yeah, Graviton, that makes sense. Don't you do gaming? I don't do it now because I don't have time left much. But maybe we'll play someday. There is this game called, what do you call, Smash Cards. Maybe we will play someday with you guys. I will play with you guys too. I will put the link on stream and we'll play on the stream itself, but some other day, not today. Let's go to this problem. Slimes. Very, very simple problem. We have already solved something similar. How do we solve this problem? There are slimes and you can merge any 2 neighboring slimes into one slime. The new value would be x plus y and the cost will be x plus y as well. What is the minimum total cost to incur to merge all of them? M candies first. I think we'll not take candies because I'm going to take some similar problem in day 6 of the workshop, and you will be able to solve candies post that. Okay, I've not like uploaded the day 6 yet because I wanted to cover these things first and then we'll do this. नहीं ऐसा नहीं है. I don't have time after work teaching, being an educator and teaching on YouTube and creating content, writing content writing and stuff like that. So I don't get time after that. No, I fortunately I think I have time left. I have not diagnosed myself with anything, but I don't know. Merge element 1, that's perfectly correct. Like if you can see this problem and you can recognize that this is actually similar to merge element 1, you are done with the problem instantly. You are done with the problem, because over here we are using the form. What form are we using? Whenever you have to merge and it remains in the same order, these are always the problems that needs to be of form 4 or LRDP. Okay, this is an LRDP or form 4 problem. So the way we will do it is this. that we have this like slimes over here. So finally there has to be two slimes which will be left and they will get merged into a final slime. Okay, so only neighboring things are getting merged. So maybe some elements like this will get merged over here, some element will get merged like this from over here to here. So when you merge, let's say up till mid, and mid plus 1 to r as the separate one, so this much you know the optimal cost to getting merged with this will be found out by recursive DP. And the final value is always going to be the sum of the elements, sum of a of I in the range L to mid. Okay, and over here this is going to be sum of a of I in the range mid plus 1 to r, and this is nothing but dp of L mid plus 1 to r. And then finally to merge these things you're gonna get the sum of these two things, which is you even don't need to know the final sum over here, because the cost of merging these two elements is going to be sum of ai from L to r, sorry. So simply this plus sum of a of I L to r is going to be the answer. So just take the maximum across all mids, that should give you the answer. Okay, and summation of L to r you can find out by looping also, or you can also maintain something called as prefix sums. Okay, both of these are feasible. So LRDPs, we have solved harder problem than this in LRDP already. Okay, so you can solve this directly like this. Okay, clear to everyone? Triangulation is one of the most beautiful problems that I think I have solved, at least in LRDP, because you cannot really think about DP in like geometry. That is very nice problem. You can see that on the day 5 part 3. I think it is a bit difficult problem, but I thought maybe we should include that one, because I have seen certain, like, that is one of the new ideas that someday somebody will put up in some contest, some Indian contest for sure, and that day whoever knows it will be able to ace that test. So when I prepare in general, like for like harder contests in general, that is going to be my preparation is mostly in the rounds that, okay, what is a technique that has not appeared recently, because someday somebody is going to pick it up and give it, and on that day I should be able to solve it up. That's only the thought process. So you need to cover so many things that is not even asked in a recent ways, or has been asked in some remote Japanese contest or Chinese contest or Russian contest or some other Olympiad or somewhere, some other trick that is there. So that is how you prepare when you're like at a very higher level, or let's say you're preparing for world finals or so, but not at this stage. For this stage you need to rely on people finding things for you. You cannot really judge what is good problem or not, right? That's it. Okay, what's the next problem on the list? We have done with K. I think we should go to L. This is one good problem. I will do one more problem after this, which is N. I will briefly talk before going into, okay, we are done with N, right? And are we done with K? Okay, no, we're not done with K. Okay, I will quickly talk about S, M and E. Okay, these three things. So digit DP we will take up in a separate video. This is a very simple. So if you guys have ever thought about digit DP being hard, I think if you know form 1, okay, digit DP is the most easiest thing that you can know about. I mean, it's very simple. It's not at all hard. It's just people have made it more harder DP form, whereas it's actually very simple. It's form 1 with one extra state that you keep. Okay, but we will learn about this digit DP at some point in time. S is digit DP, so I'm skipping this one. Okay, candies is something you will be able to solve post watching day 6. So I will upload the day 6 content very soon. Okay, but for now we'll do the questions of Atcoder today, and then some CSCS, and then we'll go to day 6. Okay, Knapsack 2. This is one knapsack problem where we talked about state rotation, right? This is something that I've discussed in one of the videos. Try this problem on your own. Candice doesn't really require any optimization, but it's a good problem. So try it after watching the problem that we discussed in the like, I mean, it's an optimization only, but it's a nice code. So like watch the like day 6 question, and then we will be able to solve it very easily. Okay. Yeah, we will detail. So this is what I'm leaving it for today. I'm not doing it today in Atcoder stream because all the other things are like standard forms. This is a bit twisty, but we can actually solve this directly also by just rotating the states and changing the meaning, but it's not in confirmation with the let's say the framework that we have learned, because the meaning is something which keeps us different. So this is one exceptional problem. Okay, exception problem out of the rule. In the optimization, in the day 6, I'm going to put some questions where we have state rotation, where we have certain sorting criteria maybe, then we have certain some optimization ideas. So those all things we'll cover in day 6. But day 6 is a bit harder, so I'm just kind of keeping it a bit away so that you guys can understand the rest of the things for now. Okay. Let's go through this K first and then L. These two questions we'll do next. These are also good questions, specifically L. Because there is a nice idea that I want to quickly kind of for you guys to remember. Personally, I feel that I sometimes make certain points which are much more like a rule based and a much more deeper concept that you can kind of retain for yourself and use it in other problems. That is what is something I feel I am good at as an educator, that I can extract out like patterns out of problems and give you guys that, okay, this is how you think about certain problems directly. Okay, so try to pick those up in the sessions. Keystones we can choose. So this is something we have already solved, right? Rules as posters. Maybe I should get them printed and distribute to people who are like kind of regular in the classes. Posters of DP workshop. Key learnings of DP workshop. Okay. No merch and stuff. I don't need to go into those things. Form 5. Very, very simple, right? Player winning, losing. Instantly when this comes up, form 5, right? Assuming both players play optimally, determine the winner. Okay. So this is, have we solved similar game before? Have we solved similar problem in the day 5, form 5 problem that we had solved earlier? The one where we had to take 2 to the power m choices. So we had 2 to the power m. No, this is not bit of game. This is not bit of game. We had solved another one when we were learning form 5, which was there is x stones and you can take 2 to the power m number of stones out of it. Remember that end mod 3 magical result at the end? How many of you remember that? Do you guys remember it? End mod 3 remember magic. Yeah. So that one question is, this is absolutely same as that subtraction game. This is actually subtraction game itself. Over here is just that you have the number of transitions and custom transitions given. No. Bit of, so form 5 is different, bit of game is different. It is the introduction of the form 4, so it's in day 3, bit of game is on a different day, right? Okay, so this is the same as subtraction game. Very simply, loop over all the n different moves that you have. So you have x stones. You will move over all the different n moves. If any of them, like if after removing AI stones, if you can push your opponent to a losing state, then you are in a winning state. So that's the whole thing. Okay, so it's a very, very similar idea. If you have solved that subtraction game problem, this is a piece of cake for you. Okay, this is a piece of cake for you. Everybody agrees? Very simply, like over here, you from dp of some state x, you can go to dp of x minus a of I. Okay, if any of this, any is losing, then this is winning. If using, you're gonna loop over all I in the range 0 to k n, 0 to n minus 1, all the different n's given to you. Yeah, I mean, game theory questions are easier because it is immediate to recognize that it's a form, what do you say, form 5 problem, right? This is an easy problem. That's why it's an easy. Okay, because it's the form is very, very imminent directly. For other things, you have to think a bit. What do you keep as the other state parameters? In the game problems, you don't really have anything on this side also, right? So that's the thing. Okay, let's move on. Let's move to the next thing. Let's move to the DQ problem. This is I think one of the good problems on the whole problem set, because you have to understand the meaning of this one, and this kind of is non-natural to some certain degree maybe if you think about it, but I mean the transitions are very simple from the point you recognize its form. So you are given that you have an array and remove element at the beginning or at the end of A. the player earn X points where X is the removed element, right? Whoever takes out, you can take the first element, you can take the last element. Whoever takes out the element of a certain value, he gets that point. So you have to tell me the total score at the end of game. And Taro tries to maximize his score minus the opponent's score, and opponent tries to minimize this or maximize Y's minus X. So everybody is trying to pull up his own score as well as to reduce the opponent's score. So it's like to make the gap they want to win with the maximum gap possible, right? Just like any other game, right? I want to beat the other person with the maximum gap possible. Okay. So we need to find out if things happen optimally, what is the final result of X minus Y? I mean, what is going to be the optimal final score of X and Y? You can find out the score as well if you want. Okay. Great. So we need to find the optimal value of X minus Y. Yeah, it's not a fair play, to be very honest. True. I mean, it's not the moves. I mean, it's a fair play. It's impartial to certain sense, but yeah, I mean the configuration is changing quite a lot, so that's there. So over here, you can try and see, like, this might seem greedy at start, but it is not really a greedy because it's optimal to kind of like wait for the first move at times. Like, it might seem that it's a greedy thing. So 2, 10, 3. So in this case, you should wait and you should take this 1 over here so that your opponent takes either of them so that you can take this 10, right? So you can wait and play. So there are multiple strategies over here, right? Right. So over here, what we do is we use form 4. This is very, very interesting. So you have A1, A2 up till A3, AN. So at any point in time, you might remove some number of things from this side, some number of things from this side. So the game will be played on a subarray always. So the configuration of the game can be represented by an L and R itself. So we will have DP of L and R, okay, which is going to mean if P plays first, whoever player P is, there are two players P and Q. If a certain player plays, so whenever you're deciding game problems, right, keep this in mind. Whenever a certain player is playing at this configuration right now, if P plays first, what is optimal score of P minus score of Q? Like, whoever plays right now, what is the optimal score, his score minus the opponent's score? Okay, we will not keep the score with respect to the original player. Who is player 1, player 2? I don't care about that. Whosoever is playing right now, what's his optimal score that he can get from over here minus his opponent's optimal score? Okay, this is what the meaning of DP would be. Is this clear to everyone? So think about this. Tell me what this would be. Okay, this is 0, 1, 2, 3. Tell me the value of DP of 1, 3. Tell me the value of DP of 1, 3. What is the rating range of D problem? 22 to 2400 at least, I think so. Sometimes you can see similar problems at the range of 2600 also. Score gap, yes, that makes sense. It is very competitive to crack broad-based companies on off-campus. Yes, that is true. That is obviously true. Yeah, there is a bigger competition pool. Whoever is playing currently, yes, that's correct. I've still not got the correct value. Think about it. 5, 7, no. 6, no. Think about it. I think now I got the correct value. -5. Why? Whoever is playing over here, what is his base score? Irrespective of clicking this, your opponent is going to take the 10 and you're going to get the 3. So your score is going to be 5, your opponent's score is going to be 10. So the optimal that you can make, whatever you move, is the best you can make is -5. Is this clear to everyone? What is the meaning of this DP state? Yeah, Zugzwang makes sense. This is a Zugzwang position, but 5 forms are enough for problems under rating range 2000. with a pinch of observation. Yes, sometimes you get bitmask dp also, but those are easy only. You don't, it's not that hard. Post you learn this. First let's focus on this. I'm going to tell you what to learn after that. Till 1800, yes. Okay, what is zugzwang? You guys know, in chess, like whatever you move you lose, so that position is called zugzwang. Okay, so let me ask you one more problem then. What is the value of dp of 0 to 3? Tell me this then. Let's see if you guys can calculate it out. If you play optimally, what is the score that you get out of 0 to 3? Let's see if you can solve this one. This is dq L problem, I guess. This is the L problem, dq problem. Can we start solving dp without watching? Yes, I mean, if you start with a dp workshop, if you know basic recursion and you go through the workshop, you should be able to solve everything. This doesn't have a prerequisite or anything. 11 minus 5, yeah, makes sense. It's a 6, right? This is 6. Okay, so now let's try to find out how do we write a transition for this. This is the state. How do we write a transition for this? Very simply, very simply, dp of L to R, it's my score minus opponent score. Okay, what I can do two things. I can take the first element or the last element. Okay, so I will get A of L. Okay, this will be added to my score, plus now it's my opponent's turn. Okay, and he will be playing in the range L plus 1 to R. So in the L plus 1 to R, if he is gonna play optimally, so he is gonna get a score difference. He will make a score difference of dp of L plus 1 minus R, comma R. This is his score minus my score. But I need to find my score minus his score. So I'm gonna subtract the dp of L plus 1 to R. This is very crucial to understand. Let's try to understand it one more time. Okay, dp of L comma R is going to be equal to A of L, which is my score, minus my opponent's score. Okay, that he will make throughout the whole progression. Now post this move, for my opponent, like x plus my opponent score minus my score is going to be the value that is returned over here. So to get my score minus opponent, I have to reverse the direction and then add it to the thing. So I will minus and then add it to the thing. Okay, so in this range, my opponent score minus my score is going to be equal to this. Minus of this will be my score minus opponent of minus my score minus opponent score in this range, and then I add that. So I add minus of dp of L of R. So we subtract dp of L plus 1 to R. So this is the most crucial step of this. If you have got this idea, then you are almost done with the problem. But this will take one more like kind of thought on your own to understand why did we actually subtract over here? Why not add? Because in this range, my opponent is first player. Over here, I was the first player. So in such setups where you have score of current player minus opponent's player, you subtract the next move because you flip the direction of those patterns that you get. So just to understand, let's say the first one was A1, then the opponent was getting A4, plus you are gonna get A3, minus opponent was gonna get A2. Okay, this was how the play was gonna happen. So you are going to get A1. Okay, dp of L plus 1 to R tells you what is the optimal the opponent can get, and that is going to return nothing but, so let's say A2 plus A3 minus, sorry, A2 plus A4 minus A3. This is what this is going to return. Okay, over here this was 1, 2, 10, 3. So I will take 1, opponent takes the fourth one, let's say 3, you take the 10, I take the 10, and the opponent takes the 2. Okay, this is going to return what is the optimal score over here. So that is going to be 2 plus 5 minus 10. So that is going to return minus 5. But for me, A1 is 1. For me, A1 is 1. This part is nothing but minus A2 plus A4 minus A3. which is nothing but this particular term. So I can plug it in over here, and a1 minus dp of L plus 1 to r, which is going to be equivalent to 1 minus minus 5, which is going to be equal to 6. That's what we were getting earlier. Is this now clear to everyone? How did we get the minus sign over here? This is the most crucial part of the whole transition thing, whole of this problem. If you got this one, then you are done with this problem. Clear to everyone? Yes or no? So tell me the next step. Tell me the next transition. If you can tell me that, then I will understand that you have understood this one. Tell me the next step, the other transition. If you take the rth element, tell me the rth transition, and then we would be, I think you would have understood the whole thing. That's correct. So we will get a of r. Obviously, we will again keep minus and dp of from L to r minus 1. Since we took the rth element, so now you are left with this much of the range. Clear everyone? How did we solve this one? And with this, you are going to get the, and if you call the dp of, let's say 0 to n or n minus 1 or whatever 1 to n, you are going to get the optimal answer in the starting range itself. So that is the question that is asked to you. So that will be all that is there for this particular problem. And if you have understood this, you even like we have our magical formula with us. Simply there are only two transitions, and there is like n over here. So this is going to be an O of n square dp, right? Number of states n square, two transitions n square. So we will have an n square solution for this. 3000 is fine for n square, and we can solve it with this much, right? So that's almost all the problems that you guys have as till the medium range, till the using the first 5 basic forms that you can solve. D problem is there, which is also knapsack, but I didn't take it up because knapsack we have solved many times for now. So you guys will be able to solve that very, very easily if you have watched the videos, right? Now this is a very good question that Priyans has asked. Okay, I think I see address this too. Do I think it like this when I solve any problem? Definitely these transitions, I think it this way itself. But do I think in terms of forms? It turns out that now I have practiced so many questions that all of these things happens in 1 second itself. So like for me, like you cannot really differentiate these phases in mind that I'm thinking about form, I'm thinking about state, I'm thinking about transition. All of these things happens parallelly altogether. So like since I have practiced so many things, so I don't really think about it this way now. I mean, I would say my mind thinks it this way itself, but you can't differentiate them when I'm thinking about this. Okay, so in that sense, like these are very, very obvious to me now. Like I should not say I'm not bragging about myself. It's more about just to be that at this level it seems all easy to me now, or else for a harder problem you have to think about constructive states. That time it might become harder, or you need to optimize certain transitions, so you need to think about data structures that might be used. So that would be helpful, but yeah, that is there. Yes, that is true. Like the way I have taught you guys what to keep as a state, I think it the same way only. Like what is required to maintain the transitions. That is, so how did I create these forms, right? How did I create, or how did I think about these problems or forms that when I'm teaching about them? That's how I think only. That's all. I mean, I'm not saying that I don't think it this way. I'm just teaching it for the matter of fact. It's just that if you see me coding now, all these steps like checking the time limit, checking all these things happens very, very fast. So you're not able to differentiate me in these 5 steps. That's it. Okay. That is true. I'm slowing it. Yes, true. So like at my end, like these things are very, very obvious now. So I obviously need to, when I'm teaching, I need to. So this is also very difficult for many people, right? Like I have seen so many people who teach well, but they sometimes teach well because they have not attained a very senior level in competitive programming or DSA. And there are people who don't teach well and they have attained very well. So getting the teaching skills and like being very good at CP or DSA is very difficult. And there are many people who do both the things as well, and kudos to them too. But I've seen many people struggling with teaching when they have attained a very senior level, because for me everything is simple, right? Obvious, it's very, very obvious, but it is not that obvious on your end, right? So I have to try and explain from your perspective that okay, this is what I might be thinking. Yes, true. my brain is now trained, so I don't need any backward propagation now, but you guys would need it. But yeah, आपका practice strategy. So my practice strategy, if I had to, I generally do it is like I'd try to think about like topics and then practice topic wise itself, or give practice contest with team if I'm giving some for ICPC. That would be my practice strategy if, at this stage, if I was giving this ICPC or things like that, or my individual contest. Give contest. I think I had made a post on LinkedIn back sometime that give contest, find out what you're weak on, practice that topic. If you're done with that, practice randomly. Finally, you get to the next contest and then give the next contest, right? Topic rating, yeah, rating range. Like I keep, like if I'm practicing on code forces, which I do very rarely nowadays, but if I'm practicing, I would like go and set, let's say 2400 to 28, 2900 and practice over here. That's how I do it. Yeah, that is correct. Like explore the channel, guys. So both videos, there are many videos that you would find uh, you'd find a lot of interesting content. Okay, so that would be all for today, guys. It's already past 12. I've taught you guys most of the interesting basic form based DP problems on the Atcoder contest. The next few are either like tree DP, digit DP, bitmask DP, these things. But we will be able to solve these things, right? When will form question be discussed? Which form question? Oh, okay, that one. That I was planning on weekends itself. Okay. Google form. Yeah, I will take it on weekends. Okay. Chalo, I guess that will be all, guys. Thanks for joining in for tonight. I hope you guys got some learning out of the problem discussions that we had. Uh, I hope you guys keep practicing. Watch the form videos if you have not. Watch the day till day 5. I've uploaded it yet. I think soon enough day 6 would be up as well. Watch them, and I hope you guys ace TP very very soon. Okay. Hello then. That will be all for tonight. Good night, everyone. See you all in the next word, next meet, next session. We are here for 3+ months. Life, it's very difficult for me to be on 3+ months. That's very honestly, I cannot commit on more than the DP workshop, because like creating DP workshop, like I used to stay up late, make the videos and upload it the next day. That's how it was. It's very difficult, but I will deliver content, don't worry. I paused in a bit between because there was a lot of work. I got some time recently, but again I think there is a bit of work to cover up. I'll do that and then I will come back again on YouTube. So it's oscillatory. Some people say that I'm not consistent. That is true on YouTube, because YouTube is like a lot of extra that like I'm trying to put on my plate, but I will try to deliver more and more. Okay, chalo. That will be all, guys, for tonight. Good night, everyone. See you all in the next live stream or in the next video. Even though it's recorded, you would be interacting with me only. Chalo. Bye. Good night. And like करके जाना stream को. Make sure that you like the stream if you have not liked it yet. And share the workshop with others also if you think somebody doesn't know, in your college juniors and stuff. Okay. Chalo. Good night. See you all in the next live stream. Bye bye. That's great, sorry.